Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 7, Section 3, Rate of Change. And rate of change, just as a heads up, is actually another way of saying or describing slope. So slope in particular is something we're going to directly address in the coming chapters. Keep in mind that what you're about to see on rate of change is actually a way to describe what slope is, and it is also a way to show you how to find slope. You will notice that how you find rate of change is exactly how you find slope. You just might use some different words, but we'll get into that in a second. So rate of change is just simply a rate that describes how one quantity changes in relationship to another, or in other words, how does one thing change when the other one does. Okay, so for example, what I've drawn on the board is a graph that shows you how much money that one person could make an hour. So if you take a look at this, after 1 hour, this person's made $10. Okay, so the x-axis represents the money made, and the y-axis represents the hours worked. So after 1 hour, $10 has been made. You can see at the other point here, after 3 hours, $30 has been made. So in this case, if you wanted to find the rate of change of this line, or the slope of this line, okay, you would want to find the change in the vertical position over the change in the horizontal position. So when going from this point to that point, when going from point A to point B, how far up are we moving? That's the vertical change. So in other words, how many hours have we worked? Okay, going from point A to point B. And then the horizontal change, it's how far left or right are you moving? Okay, or in other words, in this case, in particular, we're talking about how much money have we made? Okay, so how many hours have we worked, and how much money have we made going from point A to point B? This is how you find the slope of a line. Not all lines are going to have the same slope or rate of change, but you will use the same method to find slope or rate of change in all of your lines. And all you need in order to find slope or rate of change are 2 points on that line. So for example, if you turn these points into ordered pairs, point A would be ordered pair 10, 1, because the x-coordinate would be 10, the y-coordinate would be 1. If we look at point B, the ordered pair would be 30, 3. Okay? It's 30 because the x-coordinate, you can see that B is on the 30 for the x-coordinate. The y-coordinate is 3 because B is up 3 high. So the formula for finding rate of change as I've mentioned previously, is the change in vertical distance over the change in horizontal distance. Now don't write this down just yet. Okay? There's a simpler way to write this. Just let me explain it first. So, vertical distance, vertical represents moving up and down. So the change in vertical distance, going from point A to point B, I want to know what was the change in vertical distance? What was the change in the up and down distance? When I go from point A to point B, how much higher up have I moved, or how much lower have I moved? Sometimes you might end up moving down. So the change in vertical distance, if you want to take a look at it, we go from, there are two ways to find slope, or rate of change. They're the same thing. There are two ways to find this. Okay? The first way is to actually use the graph. Pick 2 points on the graph and then manually find it. Sometimes it's easier said than done. So we're going to manually find the slope. We start at point A because we want to know what the slope is going from point A to point B. We start at point A and we find the vertical distance between A and B. So we're going up 1, 2 spaces. So the vertical change was 2. I went up positive 2 spaces. The horizontal change, I went over 10, 20 spaces. Now the reason why I said 10 and 20 is because if you take a look at the x-axis, each slash is an increment of 10, whereas the y-axis is in increments of 1. So every time I go over a space, I'm actually moving over 10. So the horizontal distance that was traveled between A and B, the left to right distance that was traveled was 20. Because I went over 10, 20. You can see down here I'm going from 10 to 30, so I moved 20 spaces. Okay? So the change in vertical distance was 2. The change in horizontal distance was 20. So what this is telling us is that for every 2 hours worked, $20 is made. That's the rate of change, which can also be reduced. To 1 over 10. So every hour you're making $10. That is how you would find the rate of change. Some of you may be thinking now, well, why don't I just look at the first point? Not every line works that way. This line happened to, and the reason why this line works that way is because this line goes through the origin. Not every line goes through the origin. But we're going to talk about these special kinds of lines in a later chapter. It's either 7.4 or 7.5, where we talk about these types of lines that go through the origin. They have a special name, and one of their properties is that the ordered pair for the first point after the origin is, or any point on these lines represents your slope or your rate of change. But once the line gets off the origin, if it was up here, for example, the rate of change would not be so obvious. So again, just to recap, okay, to find rate of change, you're finding the change in vertical distance over the change in horizontal distance. So to do that physically, okay, to do that manually, I started at point A, and I found out how much I would have to move either up or down to get to the height of point B. Then to find the horizontal distance, I counted how much left or right I had to move in order to get to point B. Okay? Now if I had to move left, instead of putting 20, I would have put negative 20, because if you move left, it's a negative direction. If I had moved down 2 instead of up 2, I would have put negative 2 up here. Okay? Now I did say there are 2 ways to find slope or rate of change. This is one of them. The other way is to use a formula, and this way is guaranteed to work every time. The method I'm showing you here doesn't always work out, depending on the graph given to you, depending on the equation given to you. So to figure out rate of change or slope with the second method, we're actually going to use a simplified version of this without as much writing. It's going to be a formula, and that formula looks like this. It is y1 minus y2 Okay? Now these little numbers down here, this 1 and the 2, they don't actually mean anything other than a label. They're a label. Because I have two y's in the same equation or formula, all this 1 is telling me is that this y is different from this y. They're not the same thing. Normally with variables, if you see two y's, that means both those y's represent the same number. What this is telling me is that both of these y's represent different numbers. And more specifically, these y's represent the y coordinates of our 2 points that we want to find the slope of the line that they belong to. So then we also do x1 minus x2 on bottom. Now, something really important to keep in mind. It doesn't matter if you put point A first or point B first. The order of the points doesn't matter. The slope of the line is the slope of the line no matter which direction you're going. What does matter is that the y and the x coordinate of point A are either with y1 and x1 or y2 and x2. I cannot take the y coordinate of A and plug it in for y1 and then plug in the x coordinate of A for x2. It doesn't work like that. If I am going to use this formula to find my rate of change or my slope, I am going to replace the y coordinate of A with either y1 or y2. So, in this case, I'm going to choose to replace y1 with the y coordinate of A. Now, because I've replaced y1 with the y coordinate of A, my x coordinate of A has to go directly underneath it. Put in your minus signs. The y coordinate of B, okay, is going to go in y2. And the x coordinate of B has to go right underneath it. Okay? Since I'm subtracting, I like to use keep flip change whenever I see subtraction. It prevents any little mistakes as far as signs go. So I'm going to use keep the number on the left, flip subtraction to addition, change the sign of the number on the right. Same thing on bottom. So when I solve this, 1 plus negative 3 is negative 2. 10 plus negative 30 is negative 20. So my rate of change is negative 2 divided by negative 20. Or if I want to reduce it, it's negative 1 over negative 10. Okay. Same thing I got before. The only difference before was I had a positive 1 over 10, which meant that I would move up 1, right 10. The only difference between these two, between 1/10 and negative 1 over negative 10, is that this time I would go down 1, left 10, and end up right here. I'm still on my line, okay? Still on the line. Doesn't matter if I go right and up or down and left, I'm still on the line, okay? So the rate of change, you technically have two slopes or two rate of changes that work, because if you also remember your multiplying and dividing rules with integers, a negative divided by a negative is a positive. So negative 1 over negative 10 is actually equal to 1 over 10. So the question might be right now, why does this y1 minus y2 over x1 minus x2 thing work? If you remember correctly, we said that rate of change is the change in vertical distance, which is what subtracting your y coordinates tells you. By taking the coordinates of my 2 points, I have my 2 ordered pairs right here. I have A and B. Here's A, here's B. Their y coordinates are what move them up and down the y-axis. And when you subtract two numbers, subtraction finds for you what's in between those two numbers. Okay? So when I subtract 3 and 1, okay, because A's y coordinate's 1 and B's is 3, when I subtract 3 and 1, it's going to tell me that there's a distance of either 2 or negative 2 between these 2 points. It all depends on which direction I'm going. If I'm going from point A to point B, then there's a positive 2 distance between them. I'd have to move up 2. If I'm going from B to A, there's a negative 2 distance because I'd be moving down 2. Okay? So by subtracting your y coordinates, the 1 and the 3, it's going to tell you the distance vertically between points A and B. Because remember, when you subtract, it tells you what's in between those two numbers. When I subtract 10 and 7, it's telling me that there are 3 spaces or 3 numbers between 10 and 7. Just like here, when I subtract 1 and 3, it's going to tell me how much space is between the numbers 1 and 3. If I were to make a number line, I can kind of illustrate that for you a little bit better. Here's 5, here's 10, here's 0. If I were to do 10 minus 5, so 6, 7, 8, 9, okay? Doing 10 minus 5 is going to tell me what's between 10 and 5 on the number line. So it's going to tell me how much space there is from here to here. And there's 1 space, 2 space, 3 space, 4 spaces, 5 spaces. If I were to do 10 minus 6, same thing would happen. Starting at the 6, here's the 10. What's in between them? There's 1, 2, 3, 4 spaces. So when you subtract, it tells you what's between two numbers. So by subtracting my y coordinates, which are the coordinates that move me up and down, they tell you how high each point is. The y coordinate for point A, which is 1, tells you that A is 1 unit off the ground. The y coordinate for B is 3, which is telling you that B is 3 units off the ground. Okay? The x coordinates tell you how far away from the origin the point is. So in other words, the x coordinate is telling you how far along the x-axis you've traveled. So by subtracting my two x coordinates, I'm going to find out how far apart my 2 points are horizontally. I'm going to find that horizontal distance between them. I'm going to find out how far apart on the x-axis they are. Because point A is at 10 units, and point B is at 30 units on the x-axis. So if I subtract those two numbers, the 30 and the 10, it's going to tell me how much space horizontally is between them. And that space is represented right here. Okay? Or if you want, up here. That space is represented. Okay? That horizontal distance between those 2 points. In this case, going from 10 to 30, you're moving 20 units. So they are 20 units apart. So, go through this one more time. Okay? This time I'm going to switch it around. I'm going to actually put the point B as my 1s, because you can do that. It's okay. As long as the coordinates for point B are both in the 1 slots. And make sure you remember that the y coordinate goes on top, x coordinate goes on bottom. Y coordinate goes on top, x coordinate goes on bottom. Okay? So you can see that right here is point B, and right here is point A. Okay? If you do 3 minus 1, you get 2. 30 minus 10 is 20. So my slope, or my rate of change, is 2 over 20. Or if I want to reduce it, it'd be 1 over 10. For every 2 hours I work, I make $20. For every hour I work, I make $10. So this formula right here, you want to write that down. This is, and above it, you want to write, this is how you find rate of change or slope. The y's, again, represent the vertical distance between the 2 points. The x's represent the horizontal distance between the 2 points. Okay? If you need to pause the video at any point, please remember to do so. And again, rate of change or slope is describing the change in quantity between the change of one quantity in relationship to the change in another quantity. So every time the hour changes, okay, every time I increase my hours or decrease my hours, my money also increases or decreases. That's what slope is telling us. Slope can also be used, or rate of change can also be used to help us graph a line. That's something we'll talk about a little bit later. Because no matter how many times, once you know the slope of the line, as long as I start at one point, for example, the slope of this line we said was 2 over 20 or 1 over 10. So once I know the slope, as long as I have a point on the line, I can use that slope to get to an infinite amount of other points. So for example, if I use this slope, because remember this is the change in vertical distance over the change in horizontal distance, or the change in y over the change in x. Okay? So my y coordinate will increase 1, so I'll go up 1. My x coordinate will increase 10, so I'll go right 10. And I'm on my line. Up 1 over 10. Up 1 over 10. Up 1 over 10. You're always on your line. So that's something we'll talk about in a later chapter as well. But that is actually it for Chapter 7, Section 3. There are no other videos. If you have any questions, let me know.